Cognitive load theory is a learning theory that's concerned with the learning of complex tasks and the effort that has to be put forth in order to learn those tasks. The idea is that if a learner's working memory is overloaded with new information, the learner won't be able to, or it will be more difficult to, learn a complex task. John Sweller is the theorist behind cognitive load theory. His theory sprang from the idea that learners can be bogged down by the complexity of a task because a working memory can only hold so much information at once. Sweller's theory is related to Miller's magic number 7, plus or minus 2, which is right up here. Both theorists agree that human working memory can hold and process a pretty specific and small amount of information just at one time. Once new information is learned and added to our long-term memory, then we can recall it when necessary. Some key concepts related to cognitive theory are working memory, previously known as short-term memory, intrinsic cognitive load, extraneous cognitive load, and germane cognitive load, and then schemas and long-term memory. According to the theory, intrinsic load comes from the difficulty of the task to be learned. This difficulty cannot be changed by instruction. It seems that extraneous cognitive load should be the most important to the instructional designer because it refers to the unnecessary cognitive requirement that can be placed on learners, which really has nothing to do with the task to be learned. This can be taken care of in the design of the lesson. For example, a student may be asked to compare the information in a paragraph to a graphic on the back of the same page. Having to flip back and forth would place unnecessary load on the learner. Germane cognitive load refers to the work the learner has to put forth in order to transfer knowledge into the long-term memory. Now the learner has a schema in which the new learning fits. As I mentioned before, the instructional designer can play a major role in decreasing the extraneous cognitive load for a learner. One specific instructional design model comes from Van Marenborg. The model, called the 4C-ID model, consists of 4 components: learning tasks, supportive information, procedural information, and part task practice. Other ID considerations would be providing hints and prompts, think aloud modeling, process worksheets, and giving part of a solution as support while learning a new task. These instructional design concepts, of course, move us directly into some examples of how the theory could be applied in a unit of instruction. One example of lessening the cognitive load would be to provide learners with already worked problems of math equations, for example. Providing students with an entirely worked out equation would take away the extraneous cognitive load, leaving room for their working memory to work with whatever new concepts are required. Another example mentioned by Kirschner is the idea of collaborative learning. It essentially allows learners to use their collective working memories as a way to spread out the cognitive load. Cognitive load theory definitely has its share of conflicting viewpoints. One of these is constructivism, which states that the learners construct meaning for themselves. Learners may be given any amount of information related to whatever prior knowledge exists in order to create a wider knowledge base than before. Cognitive load theory would suggest that constructivism places too much cognitive load on a learner by focusing on methods like project-based learning, the case method, problem-based learning, and competency-based learning. With these kinds of whole tasks, you may run the risk of learners having difficulty because of the complexity that is involved. And that is cognitive load theory.